Hello friends, so we are here presenting the video for our project under the topic Technical Answers for Real World Problems ECE 3999 from VIT University. We are working under the Professor Yogesh Kumar Chokikar. So our topic for presentation is creating a technically viable product procedure for blind people to see using their ears. And so this is the beginning of our project. We'll move to the PPT, explain brief about what is going on in the project, and we'll eventually guide you through our main prototype and the product. So yeah, so we are four team members: Karan,
Kunal.
Hi, I'm Jay.
And hi, I'm Medha.
So now this is the work contribution from all of us. So you can see so basically our problem, our main idea about making this product is to help the people who are blind and cannot use the traditional Braille methods to read and write, and provide them with better solutions which are digitally viable. So our product name is supposed to be My Smart Eye in the for the starting of the company. And next we are moving to the problem definition. So main problem definition that comes over here is Braille is under threat from new technologies. The first thing that is main issue is that it is not that vulnerable, and it is not that widespread in the domain where people can know about it. So it requires a lot of effort from both the parents as well as the children who are learning it, as well as maintaining it is a cumbersome work because it has a lot of pages going on for reading and writing. So I'll hand over to Medha.
So what is the main drawback? So it is basically difficult for the sighted to use. That is why, like in the past also, it has been under threat. There has always been technological development that is around it that has caused threat to its history and its development. So next slide, I'd like to present how do we hear a sound and see a color. So in the trials of sighted people with no training, they were asked to match sounds to images, while the blind subjects were asked to feel textures and match them to sound. So tactile textures can be related to visual textures pattern like topographic map. Bright regions of an image translate to height level relative to a page, while darker regions are flatter. So this is how we divided both the subjects, like the blind and not the blind, and tested them on it. One common example is of cross-modality, like we have mentioned it. So it is a condition in which synesthesia disease, which is the activation of one sense, leads to a different involutionary sensory experience, such as seeing a certain color when hearing a specific sound. So this is one of the experiments we did.
So, why the brain cross processes? Like images and visuals, sound also possesses spatial qualities. Like while processing images, our brain maps the objects into like puzzles and fit them together like a puzzle piece. Auditory regions are also activated while hearing a sound, as well as like the visual regions. So these neural connections pre-exist in every human being, and we are using this as a starting point for our project.
So MVP, what is basically MVP? MVP is the minimum viable product, and the name of our MVP will be My Smart Eye, and we'll see what is going to happen. So what we'll do in that, the first we will take the image as an input, and using the machine learning algorithm we will recognize the image, what is present in that image, and we will detect all the objects in the image, and we will play sound according to them. For example, if there is a cat, what we have detected, we will play the sound of cat. If we have detected a dog, we will play the sound of the dog. So that all the sound mixing is achieved according to the probability of the presence of the object. So if we have a certain criteria, if our probability will be more than that, we will put a sound of according to that. So what will be our final product? We will be working towards the final algorithm of converting the colors of image after the launch of the MVP, because the thing is that we can see that we cannot give everything in the beginning, so we are planning to develop a new sound for the different colors, so that when we train the people or customers, that it will be easy for them to guess the sound, and according to that they will get the what is in front of them, and they'll able to see it. So what is the name of our final product? That will be the Hilbert gauge. Why Hilbert gauge? Because we are using the Hilbert transform to change the two-dimensional thing in one-dimensional. For example, image is 2D, and we will be changing in a sound that will be the 1D, and you can say see how we are changing it. It's a Hilbert gauge, and you can see the graph of also. So that will be device manual in the data sheet. It will be explained by Karan.
So coming to device manual and data sheets, we'll go to the document directly, and will try to explain you what we have written in it mostly. So the device manual consists of what kind of our product is going to look like, what is the packing, how is it going to be looking, what is the app interface. So now basically, as you can see in the application interface, we will be having an input image, and then corresponding after applying the machine learning model, will be detecting whether what is the presence or what kind of object it is. So realizing that in this object it is given a dog with a 65.578% probability, we will be playing the sound of a dog. So now this product so now this is assisted by taking the image through an spectacle, in which the specs are supposed to be looking like this, and we'll have a small camera over here. So and this is the way our box is going to look like. So now it is very simple to use. We have to just unbox, connect it to your specs, where, and just look. So basically this just provides you the most simplest solution that is there in the market for blind people to see. Now coming to the specifications, for now we are for the prototyping phase, we have been looking at a few features which are low cost, low power, high availability, high reliability, and all this are in the very beginning are to an extent achieved by using Raspberry Pi and its camera. So that involves basically using OpenCV library. So coming back to the presentation, the technical specifications are basically we are using Python Image AI, TensorFlow, Machine Learning, OpenCV, Keras, Snack Sound toolkit, and Hilbert space fitting curve, which is the power of infinite math, which we are going to exploit in the near future as of our final product. So technical specifications and the final working of the project is supposed to be in a way where we have developed the TensorFlow model on the back end, and which actually helps us to detect the objects using the COCO dataset. So these are the snapshots of the code that we have been using, taking you to the code. So this is our code that we have written. Now here so basically here what we are doing is giving an input as an image which is called which is named as download.jpg, and the download.jpg image looks like this, which is a simple image of a dog. So now our model, after running this, is going to save this and give the results. So this is the probability that a dog is present. Next step is saving this image as another image. So we have saved it as a.jpg, and as you can see in this we have a box segmented in the image which actually says that this is a dog. Now corresponding to this, basically what our algorithm will do is, as the dog is being detected, it will be playing the sound of a dog, so which you can hear from the Now here one more thing that you can see is these are the box point arrays which is giving us the pixel values where it is supposed to be there, and the percentage probability. So basically our idea is, for example, if an image there is a presence of dog if there is a presence of dog and a cat, so basically the sound will be played according to the distribution that the probabilities have. For example, if a dog is dominant in the picture, the sound that will be played is going to be dominant for dog and will be less dominant for cat. So basically the person who is actually listening to that sound can deduce that there's more dog present in the image as compared to a cat, or more water present in that image as compared to land, for example, if given a landscape. So yeah, this is our thing, and this is our final video YouTube link for TAR. So thank you.